So in the next few clips you will be seeing, I will be explaining the video project solutions for all the answers, 1 through 3. So number 1, it says, a herd of animals is growing. The population after T years is P of T animals. Each of the formulas below represents each of the following. So number 1, it says, the integral from 0 to 5, the antiderivative of P of T dt. And that is going to give you the accumulation of P, which is C. For number 2, it says P of 0, and that represents the population after T years, which is 0 in this situation, so P of T, the T value has a 0 in it, so that gives you the answer A. For this one, it's 1/5 the integral 0 to 5 antiderivative P of T dt, and that is the average rate of change in the number of animals, so that means for number 3 it is D. And then for number 4, it's 1/5 the integral 0 to 5 pt dt, and that is talking about the average size of the herd in the first 5 years, and that is letter B. And then this one is talking about the average rate of change because it's the new value minus the old value divided by the number of years, which is 5, and that is D. So in number 2, it's saying the integral cosine x to the 2/5 sine x dx, and you need to find the inner piece, which is cosine x, and that will become your u. So u equals cosine x, du equals the antiderivative of u dx, and then du equals negative sine x dx. So then you take integral negative u to the 2/5 du because negative sine x is negative, and you can move the negative sign outside. And then in order to solve this, you need to use the formula, which is x to the n plus 1 divided by n plus 1, and you solve that, and you will end up getting, once you do it to the 2/5, negative 5u to the 5th root u squared over 7, and then you return the substitution, so you will get replaced by cosine x again, which will make it become negative 5 cosine x times the 5th root of cosine x squared, all divided by 7. But then after you get that, because you returned all the substitution, you still need to add plus c because you need to add your constant to the equation. So in number 3, it's the integral 4 to the 2 plus natural log of x divided by x to the dx. And you need to find what is the inside of the equation, and that is u will equal 2 plus a natural log of x. So then du again is the derivative of u to the dx, and du equals 1 over x, once you figure out that the natural log of x is 1 over x. So then you could go back over to this equation, and you could figure out that the integral is broken up into 2 pieces. So the 4 to the 2 plus natural log of x is 4 to the u, and you could separate it, so it would be times 1 over x, which is du. So then you could say the integral 4 to the u times du, and then you could eliminate that, and it would be 4 to the u divided by the natural log of 4 plus c, but then you still need to do the substitution because there's still that u up there. So since u equals 2 plus the natural log of x, you bring it down and it will become 4 to the 2 plus natural log of x divided by the natural log of 4, so we're just the same thing as that, plus c, which is your constant, which you need to add to every equation for integrals.